Hello and welcome back, algebra students. You know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. Okay, we want to solve the system of linear equations by graphing. So the first thing I'm going to do is make my pen a little bit bigger. There we go. First thing I'm going to do is I'm going to solve each of these for y, so that I can have these in the form of y equals mx plus b, and it will make it much easier to graph that way. So for the first equation, I can see that if I just subtract by 2x on both sides, that gives me y by itself. So the first equation is just y equals negative 2x plus 5. And we did that by subtracting 2x from both sides. Okay, awesome. So that is equation number 1 all done and dusted. For equation number 2, I also need to move the 3x over to the other side. That gives me negative 2y equals negative 3x plus 4. But y isn't by itself just yet. I still need to divide by negative 2 on both sides. So that gives me y equals 3/2 x, positive because both the 3 and the 2 are negative, minus, right, 4 divided by negative 2 is negative 2. So 3/2 x minus 2. Okay, now I'm going to make equation number 1 red. So let's put this on our graph. We have plus 5, and then my slope is negative 2 over 1, right? Anytime I don't have a fraction, I can put it over 1. So I'm going to rise negative 2 and run 1. And there is equation number 1 on the graph. Beautiful. Now let's do equation number 2 in purple. So my negative 2 is going to be right down here. That is my y-intercept. And then my slope is 3/2. So I'm going to rise 1, 2, 3 and run 2. And look at that. I can already see where these lines cross. So right here at 2, 1 is the point where it looks like they cross. Now, step 3, so step 2 was to graph them, was to make our red and purple lines. Step 2 is to find or estimate the point of intersection. Step 3 is to check, is to plug 2, 1 back in to our equations and make sure that this point works. I have run out of space and I want to make sure that we have enough time to get to what we have for this video. So I'm going to leave the checking part up to you. Check that this point is indeed a solution. Okay, alrighty, but for now, let's move on to what we have for today. Today, in this video, we are going to be looking at 5.2. This is the first part of 2 parts of 5.2. 5.2 is about solving systems of linear equations by substitution. So 5.1 was solving systems of linear equations by graphing. Now we want by substitution. So we're still working with systems of linear equations, but now we're solving them in a different way. Okay, so our learning target for today is that you know what substitution is. What does this mean? I know what graphing means. What does substitution mean? And our success criteria for today is that you can solve systems of equations by substitution. You can use this substitution that we're talking about. Okay, so you need to know what it is and you need to be able to solve. All right, let's review what is a system of linear equations. What is this thing that we're trying to solve with substitution? Well, a system of linear equations, you may remember from our last two videos, is a set of two or more. For us, it's just going to be two linear equations in the same variables. So x and y and x and y. Okay, so substitution. Here are the steps. We saw the steps of solving by graphing. We're also going to look at the steps of solving by substitution. Reading these steps, it might be a little confusing why it's called substitution or what exactly substitution means. So if you are a little confused after we talk about these steps, don't worry. We're going to see two examples of this today so that you can get a better idea of what these steps mean. So step one is solve one of the equations. So remember we have two equations. I'll just make some up real quick. There we go. We have two equations, and step one is to solve one of the equations for one of the variables. Now, one of the equations for one of the variables. What that means is you're going to take one of the equations, either number 1 or number 2, and you want to get y equals or x equals. So in this example that I've made, we already have y equals, and that's step one. Step one is to get either x equals or y equals for one of the equations. So that's step one. Step two says to substitute the expression from step one, so substitute the y equals into the other equation. So we're going to take whatever we get for y equals or x equals, and we're going to put that in for y in the other equation. And I will do this in a different color. So we're going to take the y equals or x equals and put it in for y. And that is step number 2. That way we can solve for the other one. So if I have y equals, I can solve for x. If I have x equals, then I can solve for y. So substitute, and this is why it's called substitution, is because we're substituting y so that we can solve for x. Okay, and step 3, so once you do this substitution, you do some more steps and you get x equals blank, something, right? And step 3 is to take whatever you get for x and plug it back into the original. That way you can solve for y, right? Because my solution to a system of linear equations is a point. I need the x and I need the y. I need to know what x is and I need to know what y is. So step 3 is to take the value from step 2, take the value that you get from plugging y in, and plug it into one of the original equations. And then you can solve for the other variable. That will give you what y is. Now, some of you are sitting at your desk or sitting and watching this, and you're like, Mrs. Dodge, I have no idea what you just said. And that's okay. Steps can be helpful, but it can also be helpful to see an example so that we can see these steps in action. So let's do that now. We are going to solve this system of equations by substitution. So, step 1, solve one of the equations for one of the variables. And we'll write get x equals or y equals. Now today, all of the examples that we do today, notice that we already have y equals. In both of the examples we do today, we already have step 1 done. So we don't have to worry about step 1. Step 1 is right there. I have y equals, negative 2x minus 9. Okay, but now step 2. Substitute the expression from step 1 into the other equation. So we're going to take the first equation here, and we're going to put it in to the other equation. So what I'm going to do is I'm going to take 6x minus 5y equals negative 19. And instead of writing y, well, y is equal to negative 2x minus 9. So when you think of substitution, right, you're thinking of maybe like sports players, maybe like in a soccer game. If I substitute two players, one player is coming off the field, one player is going on the field, and they swap places. So this guy is playing and now this guy's not playing. It's very similar in math when we talk about substitution. Y and negative 2x minus 9 are both soccer players, and they can switch who's playing and who's not playing at any time because they're the same thing. They're both soccer players. So instead of writing y, we're going to erase that. We have y equals negative 19. I need some space. We're going to erase that y, and instead we're going to put negative 2x minus 9. Because that is y. That's what y is equal to. It's the same thing as y. Now you might be thinking, Mrs. Dodge, why would I do that? That seems unnecessarily complicated. But look at this equation. Now I have 6x minus 5 times negative 2x minus 9 equals negative 19. There are only x's in this equation. I don't have any y's. So I know how to solve this equation. I can solve this for x. And that's good because in the end, I want x equals something and y equals something. So let's go ahead and solve this for x. Anytime I see parentheses, I know I have to do my distribution rainbows. So we're going to distribute the negative 5, the 6x, negative 5 times negative 2x is positive 10x, and negative 5 times negative 9 is positive 45, equals negative 19. Okay, I can combine some like terms here. 16x plus 45 equals negative 19. I want to get x by itself, so let's subtract 45 from both sides. 16x equals, what is negative 19 minus 45? It is negative 64. Divide by 16 on both sides, and we get x is equal to negative 64 divided by 16 is negative 4. And there we go. We know that x equals negative 4. We are halfway done. Now I just need to know what y is. And this part is actually a little bit easier because now that I know what x is, I can do step 3. Step 3, substitute the value from step 2, whatever we just got, substitute it into one of the original equations. So we're going to take this x equals negative 4, and we're going to put it into one of these equations. We can put it into equation 1 or equation 2, it doesn't matter. So let's clean this up a little bit. Oops, too much. There we go. So notice that when I look at these two equations, one of them already has y equals. Y equals negative 2x minus 9. So I already have y equals, and I want to know what y equals. So let's take x equals negative 4, and let's put it in for x. So we're taking the -4 and we're putting it in for x. So I have y equals -2 times -4, because x is -4, minus 9. Okay. And then -2 times -4 is 8 minus 9. What is 8 minus 9? -1. And look at that, there's y. Y equals -1. So we found x and we found y. This is awesome. We remember that solutions to systems of linear equations are supposed to look like an ordered pair. So I can write -4, -1, x, and y. I can write this as an ordered pair. And this is the final answer that I want. In my class, if you were to write x equals -4, y equals -1, I'll give it to you also. But your teacher or Big Ideas might want it in this ordered pair form. Okay, all right, that is example 1 done. Let's make sure that we were correct. All right, so equation 1 is already solved for y. So we substitute -2x minus 9, perfect. And then we solved for x, and then we put x back in the original equation. Hey, that's exactly what we did. We got -4, 1 in that ordered pair form. Cool, awesome. We were right. Okay, now what I'd like to do is I want you to try. So using the last example we just did and the steps on the slide before the example, I'd like you to pause the video and try this problem in your notes by yourself. If you get stuck, you can unpause and watch me, but try to do the whole problem without unpausing, without watching the video. And then you can watch the video back to make sure that you were correct. Alrighty, so remember, step 1 says to get x or y by itself. Get x equals or y equals. And I already have x equals 6y minus 7. So I can plug that in for x. And I'm going to do just that. I have 4 times x plus y equals -3. And instead of writing x, I'm going to write 6y minus 7. All right, now I can distribute the 4. 4 times 6 is 24, and the y stays with it. 4 times -7 is -28, plus y equals -3. Let's combine some like terms here. 24y plus y is 25y minus 28 equals -3. And then let's add 28 to both sides. 25y equals -3 plus 28. That's the same thing as 28 minus 3, which is 25. And I want to get y by itself, so I'm going to divide by 25 on both sides. And hey, 25 divided by 25, that's 1. Awesome. Cool. So I have y equals 1. Step number 2, Step number 2 is to take what I've got for y and plug it back in to the original equation for y. So let's do just that. Let's take x equals 6y minus 7. But now, instead of writing y, I'm going to write 1. Because we know that y is equal to 1. Okay, so x equals 6 minus 7. 6 minus 7 is -1. And hey, look at that. I have x equals and I have y equals. So I can write this in the ordered pair form of x comma y. And I get -1 comma 1 because that's what x is and that's what y is. Awesome. There we go. Final answer. Yay! All right, at this point in time, it is time for you to check your understanding. On a scale of 1 to 3, where 1 is I have no idea what you're doing, 2 is, I'm getting there, and 3 is, oh yeah, this makes sense. Where are you? Think about our learning target and our success criteria. Do you know what substitution is? Do you know why it's called substitution? Do you know why the steps of substitution work? And can you substitute? Were you able to do the last problem on your own? Were you really close to being able to do it by your own? Or did you understand it after you watched me do it? Where are you on the scale of 1? If you're a 1, be sure to ask your teacher for some help or talk to a friend or watch this YouTube video again, whatever you need to do. If you are a 2, try the homework, and if you get stuck, ask for help. And if you are a 3, help a friend with your homework, or with their homework, or teach your parents what you have learned, something like that. Here are some practice problems that you can do to practice the skills that we have learned in this video. These problems are like example 1, and exercises 3 through 8 is a little bit of a different question. It asks you, which equation would you choose to solve for one of the variables? So if I needed to get, x by itself, x equals, y plus yada yada or whatever, or if I wanted to get y equals, x blah blah blah, which one are you going to solve for? In number 3, are you going to solve this equation for x or y? Or are you going to solve this equation for x or y? Which would you do and why? Make sure that you are able to explain. That shows that you really know what's going on. All right, and of course, we should always end our video with a launch. So today's launch comes from Vern McClellan, and he says, what the new year brings to you will depend a great deal on what you bring to the new year. So, I know it's probably February by the time you're watching this, but, or even later, depending upon when you're learning about this, but at the time of recording, we are in January, so that's why we're talking about the new year. So, what the new year brings to you. We always talk about, oh, I hope the new year brings me happiness, or I hope this year I have more friends, or I hope this year I can get popular, or, whatever it is. This year I hope that. Maybe this year I hope that COVID stops, or something like that. What the new year brings to you, what you get out of the new year, depends a great deal, depends a lot on what you bring to the new year. What are you bringing to the new year? Because if you bring a bad attitude and sadness to the new year, how is it going to give you happiness and more friends? If you come to the new year like, oh man, 2021, here we go. It's going to be just as bad as the last one. Like, what do you expect to get out of the new year? What you look for is what you find. If I go out looking for new friends, I'm probably going to find them. If I go out looking for laughter and happiness, I'm going to make it. I'm going to find it. But if I go looking for all the sad things about life, school still isn't open. I still can't hang out with my friends. If you focus on all of the negative and you look for all the negative things, that's what you're going to find. And it's not going to be as happy. So, if you want something out of the new year, if you want the new year to bring you something, bring that to the new year. Bring happiness. Bring a good attitude. Bring friends, or whatever it is that you're hoping to get out of the new year. Oh, that is my lunch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.